in addition to using chemical equations and reactions to calculate stoichiometry, we can also use the idea of a mole to get at what we call percent composition and use this to determine empirical formulas for compounds. Let's first of all define what we're talking about here. Percent composition is thinking about what percent of the mass of a compound belongs to a particular element. And so this is us looking at we can go from the chemical formula we have and we can figure out how many atoms. That's pretty straightforward. How many atoms belong to each in an element. For example, if we're looking at this molecule methane, CH4, we know that 1/5 of the atoms are carbon and 4/5 of the atoms are hydrogen. And so that's pretty straightforward directly from the chemical formula. This is a little bit different. The percent composition is, instead of looking at the numbers of atoms, it's what percent of the mass. Because carbon atoms weigh a lot more than hydrogen atoms, even though there's only one carbon atom in methane, in CH4, it takes up most of the mass. And we can calculate what that mass percent is based on the chemical formula. And how do we do that? We use the idea of moles. Because we can think of this in terms of atoms or in terms of moles. 1/5 of the moles of a substance, 1/5 of a mole of carbon of methane is carbon, and 4/5 of a mole of hydrogen of methane is hydrogen. And so that's the basic idea of what we're going to do. So let's go through an example with methane here of how we can calculate what's the percent composition in terms of the mass of methane, how much of it is carbon, how much of it is hydrogen based on mass. Now, how are we going to do this? Well, let's consider 1 mole of methane. And what's the mass of 1 mole of methane? Well, it'll just be equal to the molar mass. So we know how to find that. Molar mass is going to be equal to 12.01 grams per mole. This is the value for carbon from the periodic table. And we need 4 times the value for hydrogen, which is 1.008 grams per mole. Again, we can go look these values up, which is what you should do. And then we can add these together to get, let me not do this, try and do this in my head, but let's use the calculator. 12.01 plus 4 times 1.008 gives us 16.042. All right, so we know that's the mass of 1 mole of carbon, of methane. I keep getting this mixed up. But what we're going to do now is see, well, what fraction of that is carbon, what fraction of that is hydrogen. So we know that, as we said here, that for every 1 mole of CH4, we have 1 mole of carbon atoms and 4 moles of hydrogen atoms. That's just based on the chemical formula. And so we know that the mass of 1 mole of carbon is 12.01 grams, and 4 moles of hydrogen is equal to 4 times 1.008 grams, which again, we'll put that into the calculator just to make sure, get my math right. 4 times 1.008 gives us 4.032. Okay, and so in 1 mole of methane, we have 16 grams total, 12 of which is carbon, 4 of which is hydrogen. Just rounding the numbers here. And so if we want the percent then, our percent composition, so our percent of carbon will be equal to the mass of carbon in 1 mole divided by the mass of 1 mole of CH4. So and then to put in a percentage, multiply by 100%. Okay, so we'll have our 12.01, this value here, grams, divided by our 16.042 grams, this value here, times 100%. And that gives us a value of 12.01 divided by 16.042 times 100, 74.0 let's see how many sig figs. We should have 4 sig figs. 74.87%. So even though there's only one carbon atom in a molecule of methane, because it's so much heavier, it makes up the vast majority of the mass of methane, if you have it. We can repeat this calculation with the hydrogen, and we should just get 100 minus this value because everything else is hydrogen, but we can just double check. So our 4 moles of hydrogen, we're going to use this number now. So our percent hydrogen is equal to 4.032 grams divided by our 16.042 grams times 100%. Put that into our calculator. 4.032 divided by 16.042 times 100, and we get 25.13. You can double check this, but if you add together 74.87 and 25.13%, that adds up to 100%. And so this percentage, again, is based on mass. We can also do a separate percentage based on number of atoms, but that's not as useful. Usually we care about mass. So in methane, about a quarter of it, even though 4/5 of the atoms are hydrogen, only about a quarter of the mass is hydrogen. And so this is an example of how we can find and what a percent composition is for an element. So in the next video, we'll look at another example with more than 2 atoms and also think about the idea of an empirical formula and what that means.